everyone. We're going to find the domain, locate any intercepts, and graph f of x, and find the range based on the graph. We're also going to test for continuity at x equals 0, because this is where all the actions taking place. This is where the functions change, and we're going to piece them together. And so we're going to do test for continuity first, see if this is a continuous function. All right, so the definition of continuity is right here. The first, we have to meet all three conditions in this order, and in our case, our C is 0, because that is where the functions are changing. So the first thing we have to do is just see if we have a f of C. So in our case, do we have a f of 0? So you plug the 0 into this lower portion. So we have 0 squared, that equals 0. So we do have a f of C, so condition 1 is satisfied. All right, for condition 2, the limit as x approaches C, or 0, from the left of our function should equal the limit as x approaches C, which is 0, from the right of our function. And all this means is that if you have a line, so here's your 0, that means all the numbers less than 0, what's going on with them as they approach 0, and what's going on for all the numbers approaching from the right of 0 when we're graphing. So this means all numbers less than 0, and from the right, that would be all numbers greater than our 0, which is our C. So let's see what's going on with that. So from the left of these numbers approaching from the left, that is going to be in there. So when you plug in 0, you get 1 plus 0, which equals 1. And from the right here, that means all numbers greater than 0. So we have to plug it in to the lower portion, which is 0. So we have 1 equals 0, and that's not true. So the limits do not, the left-hand side does not equal the right-hand side limit. Therefore, the limit does not exist. So condition 2 fails. That means our function is going to be discontinuous. All right, so let's graph it. We'll start at 0 because that's our C. So all numbers to the left of 0. So what's going on with the graph to the left? So we start with 0 and plug that in, and we know that's 1, but it can't equal 1. So you just do an open interval there. Now, if you plug in, so numbers to the left of 0, -1, that goes to 0. You can tell the slope here is 1. This is linear. So you can just kind of graph right here on the squares there. It goes all the way and continues on. So that's the first portion. The second portion is when x is greater than or equal to 0. So when you plug in 0, that goes to 0 here. And it can equal 0. And at 1, that goes to 1, maps to 1. So you have to, since it's a quadratic, you have to at least plot 3 points. 2 maps to 4. So you get 1, 2, 3, 4. So you can see the curve. Anytime it's greater than linear, you have to at least plot 3 points to get the curve. And we know 3 also goes to 9. So we're going to go way, it's going to get up and like that. All right, so we're just sketching it. And what you notice here is we have a jump discontinuity, because if you graph this, you have to lift your pen to go down to this here. So that's called the jump discontinuity. And that is why condition 2 failed. Because it's not continuous, because you have to do a jump. All right, now let's do our domain. Well, if you look at the domain, it includes all numbers, because it's all negative numbers from here, and this part is all positive numbers, including 0. So our domain is all real numbers. Or you could write it like this. Now let's look at our y, our range. So our y it include all our y values. So it includes it here. There seems to be a jump right here, but we do have y values in here. So it does include all real numbers. So our range is all real numbers, or again, you can write it like this. We can easily see our intercepts on this graph, thank goodness. So we have x-intercept at -1, 0, and a y-intercept, which is also an x-intercept at 0, 0. And that's it. Thank you. Have a nice day. Bye-bye.